All right, we are live. Yes, let me just make sure. Yeah, we are live. Hello, everyone. Welcome to VirtualMuleys online meetup. It's our 25th event, so we are excited. All right. Hopefully, you all can see the screen, hear me well, see me well. You don't have to see me, but still. Yeah, and the most importantly, we really hope you all are doing well. You are safe, healthy, wherever you are. So just try to stay like that. With that, the quick announcement that I have is 25th June 2020 is when APAC MuleSoft Connect is scheduled. It is online, it is free. So if you haven't registered yet, feel free to register and attend that. It's at 11 a.m. AEST time. So should be a fun. I attended the Americas one and it was fun to interact with people, to see the stations that are in there. It will be fun. So take a look at the schedule, and if you haven't signed up yet, please do sign up. With that, our today's topic, as you can see on the screen, is API governance and GitOps in hybrid integration platform. We have Sumant Tonthi with us from AIG Insurance, and he's going to walk us over this use case and how they achieved it and what they did within their organization, right? So without much ado, okay, one more announcement. Those who are joining us for the first time, there is a chat on the right side of your YouTube window. So feel free to keep talking about anything related to the presentation there. Feel free to ask questions there. Once Sumant is done with the presentation, we will go over those questions as much as we can. So we will try to cover most of them, but we have time limit. So, okay, without any more delays, Sumant, it's all yours. Please take us there.
Thank you, Manik. Good
Yep.
morning, good afternoon, good evening, wherever you are in this world. In this session, it's broken into two parts. The first part would be the API governance, and the second part is the how we've improved the operations in the hybrid integration platform. About me, I have over 15 years of experience in software engineering, currently leading global platform strategy, API governance, platform engineering and operations for the hybrid platform at AIG. Specialties, architecture, program management, digital transformation, platform engineering, scalable and distributed systems, and DevOps at scale. And you can find me at LinkedIn, right, on that link over there. So the first is the API governance. We'll just briefly talk about some of the problems we've had, the objectives, the metadata context, how we've improved our processes, and the benefits of the API governance. So the problems, we have a wealth of knowledge on APIs, but they are scattered and maintained in silos. A lot of data is missing context. We don't understand the dependencies because they are maintained in silos. So as a result of this, the troubleshooting and providing estimates has often been a challenge for us. And a lot of processes on top of that, and the teams that we deal with, they use different tools. So collecting this data, it's always been a challenge. And understanding the relationships of these APIs has been challenging for us. And we had a lot of consistent standards. Coding standards, we have different vendors who write the code, the understanding of the requirements and the quality of the code, the naming conventions. We had a lot of these challenges in terms of the design and the approach. When you're running a shop at a global scale, these are the common challenges that any major organization such as AIG, we were one of them to face. What we want to get out of this is we want to have a shared repository where we can collect the metadata and metadata information about our APIs, its relationships, integrate our technical, operational, and business assets in a central location so we have common understanding. Um, get some context out of the data, what we store there, and improve our quality, code quality, the best practices, design patterns, naming conventions. Um, Overall, we want to improve our operational efficiencies, and that's by enabling the data governance in a collaborative way. So what does the API governance context? It means different things to different groups. If you think from the product owner or stakeholder point of view, they have a vision, strategy, discovery of APIs, which APIs belong to a particular business, what's the value that they get out of it, what state the API is in. Is it in development stage? Is it going to be deprecated, or is it going to be what stage of that API is? So that's if you talk to a product owner. If you talk to a developer, he's more focused into designing how does he design an API, what standard practices he needs to follow, how does he do the versioning, how can he reuse assets. That's his focus, getting the standards across those areas. If you talk to a platform owner, that's where I come in. I'm focused more on how can I make developers' life much easier, how can I enforce standards, best practices, security standards, we want to have a consistent deliverables, and how can I automate things at scale, and on top of that, how can I keep track of things when things change. So those are the governance aspects from the platform owner point of view. If you talk from the operations point of view, they want to understand. They're on the receiving end, right? They are far end, right? The project has already been delivered. They want to understand the dependencies, the owners of the APIs and the interrelationships, the consistent logging, tracing, and monitoring. Consistent understanding of that. They want to have better troubleshooting experience, and also auditing also plays in place if you talk to an operations engineer. So what is the metadata context? The metadata context here, if you look at the technical, there are three main areas: technical, operational, and business. The technical information is what's an API, what are my API consumers, how my API is related to other APIs, how my APIs are related to consumers. If you talk asynchronous communication between APIs. If you're talking about asynchronous communications, my assets are queues and queue exchanges, how my APIs are related to those queues and queue exchanges, and databases, relationships with them. And if from the API context itself, I want to understand the name of an API, the description, the life cycle stage of that API, what architectural style it's using. Is it a RESTful call, RPC call, or is it in-house, internal API, which is part of an SDK, but not exposed as a RESTful service. So things like that, these are the basic information. What technology used, what's the scope of that API? Is it an internal API, external API? Those are the basic informations that comes under technical category that anyone would like to understand. If you go further down, we also wanted to understand the authentication scheme, the transport security scheme, what TLS transport schemes are used for that API. Request and response formats, is it XML, JSON, different formats of an API. And if you want to understand the low-level details, the specification, where can I find, a Swagger spec or a RAML spec for that any documentation. Not every API is maintained, might have a Swagger a RAML when you're talking about a huge organization. So if there's any documentation. So these are the main information at a high level, the metadata from the technical point of view. From operational point of view, those guys are more interested in where it's been deployed, who the owners are, what release it belongs to, what monitoring tools that these APIs use, and the relationships associated with that. Coming to the business point of view, which program these APIs belong, the owners, the business functions, category, and more related to the business assets. So all of this is just, if it's there in the central location, it's easy to get the context. And the context might mean different things to different groups, but you get the context, and you can start from one context and derive the information to the other areas. The delivery process before we had all this is during the discovery and the assessment phase, we used to have these constant email communication, and then we used to catalog some of it is in Excel spreadsheets, and different teams use different tools here. We used to catalog these services, and we used to send information to the DevOps person, either an email. So all of this communication is via email. And if you look at if you want to build an API in Mule, you have to set up the pipelines. You need to create an asset in the exchange, the API in the API manager. We maintain all our Spring. We use Spring Cloud Config to maintain our Mule properties. So all of that used to be done by multiple people. If you see here, the platform engineer was also doing it. The developers were doing it. They were creating repos. It was really hard to manage these at scale because we have different teams, different vendors. There were no consistent standards or enforcement. And the production operations had a lot of challenges with that, because now they have to deal with, they need to understand the dependencies, because all this information is buried in the emails and there's no context. They used to rely on whatever information that we shared, and again they have to deal with all these troubleshooting aspects of it. So discovery, provisioning, and production operations, those were the major steps. And this is what we were at the beginning of the Mule adoption. Fast forward now, we've improved our processes much better, and what we've done is we've incorporated a central data governance tool. We have an in-house tool. This is not an in-house. Colibra is a commercially available data governance tool, but we already had Colibra. We thought of building a metadata repository in-house, but later on we leveraged the capabilities of a tool that we already had. So we worked with that team, and we built an asset model, whatever metadata and the context information I just stated earlier. We built a meta model, and we started incorporating that as part of the intake process itself. So during the discovery phase, now this is more of a collaborative effort rather than emails. We would just go and verify in the discovery phase, is that API already existing? If it's already existing, then we would see whether we could leverage that and talk to the stakeholders, talk to the data owners. If there's a need for creating an API, now we leaned on to Jira. We had a Jira process now, got rid of all that email communication. A ticket has to be opened by the developer. So we had a Jira. We have a basic information of that API in this Colibra tool, and all the design first approach, your RAML or Swagger spec, all that work that's going on. That's still there. We still have your anypoint exchange link, but we just have a reference to this because this also contains the non-technical business and the operational non-technical metadata in this repository. So we have those references, the documentation links in here, And now the information is gathered, and we have a Jira ticket. This gets assigned to the platform engineer. So all the manual steps we used to do by creating, we just drive that by a pipeline. So we call this as a bootstrap process. Essentially, it's like a self-service way. So once the ticket has been approved and it's vetted out, right, we need a new API. So this bootstrap script will create all the pipelines needed for your API, dive into QA, however it is. It creates an asset in the exchange, creates the respective API in the API manager, creates your Spring Cloud config repos, and then we have a standard base templates. We have set patterns. We don't want developers to keep writing code from scratch, right? We have set patterns, and in this request we know whether it's a RESTful pattern or an async pattern or a proxy pattern. Based on the patterns, we have defined patterns, and that patterns is a collective knowledge of all feedback we've received from years of experience. We collected that. These patterns have common exception handling, common error handling, best practices incorporated. Everything is built in that, and any new change we want to introduce, we would introduce in that template. So these templates are already there in Git, and the script will take care of, and we define the naming convention of that API upfront. We want consistent naming standard for our APIs, and in the past we were not able to enforce that. Yes, we had guidelines and best practices like any center of excellence. We've documented that in Confluence, but at scale it was harder for us to enforce, and that's why we just started at the beginning itself. At the API designing time itself, we define the naming conventions, because that naming convention is used everywhere. That's the naming convention used for your Git repo, your Spring Cloud config, your assets, APIs. A dozen different places, it's the same name that's used. So we have to be very careful to work on that. And once the template, so once here I would say pick up the REST template, take the REST template, and you just it substitutes the values with that name, and that now you have a base code. The base code is being checked into your dev branch, and the corresponding Spring Cloud config repo is also created for that specific application. And when your API is created, that API has an API ID and API version. It's the way you associate your API in the API manager to the runtime manager is using API ID, so that it picks that value, and it also puts that in the respective property file, and then it just triggers your dev pipeline. So essentially, what we are doing is we're not just giving a repo to a developer. We are just setting his project, and his project is already deployed, and his API is already deployed in dev, and we already verified that it has connectivity in the appropriate environment, and it connects to the respective API manager. So that's what we are actually bootstrapping his project. So the developer doesn't start with ground zero. He's starting with 40% of the code is done in most of the cases. And in case of like proxies, like straight through proxies, 90% of code is done. So we are essentially increasing the developer productivity by speeding things up over there. And here we also, so this is more on the platform-like approach governance, and we have integrated this with a more like the business and the data centric. And here, initially the developer might not have enough information, but later on throughout the life cycle of that project, whatever information he gets, he will add that before the release, and we have a checkpoint, compliance checkpoint, before we promote that code to production, making sure that we have both the data and the API is consistent. So benefits, what benefits? As I stated earlier, collaboration. Our collaboration is improved a lot. Now the operations guy and the developer and the platform and the business, all get to understand the context of the information is there. It enables the service discovery. So when you're dealing with a global scale, oftentimes the same API gets built because there's no central place or a way to discover your assets. And so by having all these assets and APIs in a central place, it avoids, typically an API development will take about 2 weeks. So we could avoid that. And most importantly, emphasizing on employee training. Any new person that comes in, it's easy for us to just say, hey, here is the tool, go take a look at it. You get the basic information, and then and then it helps us in knowledge transfer for employees coming in and going out of the org. The service delivery, as I mentioned, the provisioning and bootstrapping of all that, now we can complete that in 2 hours, as opposed to like days it used to take because of the lead time with human intervention. The self-service model, here again, in case of proxies, it was 80% your code is already ready. In case of other patterns, each pattern has some productivity gains over there. And most importantly is the standard practices. We were able to enforce the standard practices, because when you're dealing with like 10 or 20 different vendors, code development, now as a platform owner, when this code goes to production or operations person, they want to see a consistent logging or consistent tracing or consistent way of error handling or the best practices. So having these patterns, incorporating this as part of the pattern-based templates helped us achieve that commonality across the platforms. And most importantly, we are able to get a common naming conventions and data, and we were able to also audit our requirements, like when the request was opened, who opened it, who approved it, and what stage the API was in. And so all that data was missing in an emails earlier. Now we have a central place to get those sorts of metrics. Okay, moving on. The second topic is the operations at scale, right? So same outline here: problems, objectives, our footprint, where we are right now, and what process improvements we made and the benefits we got out of it. So hybrid integration pattern, not for certain small portion of viewers over there, you might be wondering what the heck is this hybrid integration platform. So we call hybrid integration platform, it's nothing but it's MuleSoft. And why it's hybrid? Because your Mule runtime, this is your standalone clusters, and that's what the operations I'm going to talk about today. So your Mule runtime servers could be of different versions: 3.91, 90, 91, 92, 421. For every version, there's a Mule runtime MREs running, right? So these clusters could be either on-premise or it could be cloud, but we manage those. We install patches, we create those clusters, and we register them in the Anypoint manager, which is hosted by the MuleSoft. And whether it could be a runtime fabric, which is on the right side, and this can be hosted anywhere, and or your cluster hosted anywhere. All that central management console and metrics, you all get that in the control plane that's offered by MuleSoft. That's why we're calling that as a hybrid integration platform. Okay, so coming to this operations, problems, again, the cluster setup, typically the lead time would be 4 days. Installing patches took several weeks, and manually updating the server configurations, we had to deal with lots of configuration changes without any visibility into it. And it drove our operational cost a lot, because making a small change used to take several weeks and lead time, and those were the main problems. And at scale, this model definitely would not work for us, right? So what we want to achieve is to get to hours, instead of days, focus on hours, whether it's a software patch or cluster provisioning, anything that's redundant and repeatable. We just went back to the drawing board and we started jotting down what's repeatable, what's redundant, list it down, and start incorporating those changes. Um, and most importantly, we want to have a central place where we can go and find the information and all configuration changes. I should be able to go back in history and find out what exactly happened to a particular MRE or a server. Um, uh, so I should be able to get that. That was one of the objectives we wanted to lay out. And then most importantly, at end of all of this is to reduce the operating cost in maintenance. So this is the current deployment footprint. So we've started in early 2017 a detailed analysis on MuleSoft, but 2018 is when we actually had like a major workload. But the scale at which we were going is a lot, and we had to do the process improvements, and we had to catch up to be able to get up to this scale. So if you look at our Mule inventory, moved 6x. We have 600 plus applications, and our MREs are because the isolation in a standard cluster is we cannot have all 600 in set of clusters, right? They're globally distributed. So you have to have a way of separation in your MREs based on the clusters, and we define that by setting clusters. Okay, this cluster for this LOB, again, these are isolated based on the business functions, geography, region, so on and so forth, and to support the patching activity and the maintenance of, again, MREs are of different versions. So different versions have different MREs spread across on-premise and cloud. And then to maintain that, we created all these automated pipelines, cluster setup, pushing wrapper config changes. If I want to push wrapper config changes globally, I should be able to do that. So that's for the wrapper config pipelines. And patches, we keep getting patches. Every cluster or every server has a unique requirement, and sometimes there's a global requirement. You could get a security patch or a vulnerability that you want to address. You should be able to push that much faster globally, right? And again, you could have different MRE versions, different cluster versions, and then Log4j. This is another thing. What we added is every cluster logging requirement is different, and not in terms of like the format of it. The format we've standardized with a JSON format, and we're ingesting that into Splunk. But in terms of like one cluster, because of the load, they have a unique requirement of having a certain requirement of storing the logs to a certain amount of time, and having all these log4j XML files embedded within your application was also a challenge. So what we did is we decoupled them. We said every time there's a log configuration change for your cluster, the cluster might have 20, 30 applications. Every time there's a change, I don't want to deploy 20 applications or 30 applications. I want to have a minimal invasive way or non-intrusive way, right? I shouldn't be touching your applications. I should be able to, manage this outside from the platform side, and your whatever benefit you get is, yes, one cluster might have 5 archives, certain amount of logs for a certain thing, and have a specific format requirement. That's fine. So we've decoupled the log4j configurations globally, and depending on the cluster and the requirement, we have, again, standard templates based on that, and we able to push that. So any change, if I need to move to a certain clusters might want data to be loaded into a different system. So with the current capability what we have, it's easy for us to switch without redeploying and rebuilding the code. in a minimal invasive way. And the application pipelines, again, you have so many environments. If you keep growing your application inventory, that keeps growing as well. So cluster provisioning. So again, this used to happen via email, used to open ServiceNow. Again, coordination via email. The operations engineer we used to download the binaries. We used to maintain these. We maintain all the binaries in the JFrog Artifactory, and so again, a lot of manual steps. The configurations are in one place. The Artifactory binaries and licenses there. The cluster setup is done manually. Registration is done manually. A lot of manual steps, but again, there's no visibility into who did what unless we go into the service now. There's no central place to identify like what exactly happened by looking at the cluster point of view or wrapper config changes point of view, right? The wrapper config changes used to happen, by the operations team, and there's no visibility into that. So what we've done here in the cluster provisioning, all that work has to happen here. We want to understand from the platform ownership point of view. The platform owner or platform engineer, works with the developer, gathering the requirements, understanding the capacity, number of services is planning, region, geography, all that, right? So we used to do all that work here, put that in the Jira ticket, and then we maintain the wrapper config in Git. So every server, every cluster, there is a configuration of Git, and we store that wrapper config in Git. And anyone wants to propose a change, they can always open a pull request, and we look at that. And then once we approve, then everything is driven by the pipeline. So initially, you would put the wrapper config in Git. Again, the standard service now change goes to the operations team. The operations team triggers a pipeline, and that pipeline would first it would get the credentials from Vault. It will get the API credentials, and then the license is also stored in Vault. It'll get that. Then it creates this the cluster in the respective region, geography, whatever that is. Once the servers are provisioned, assuming the servers are there, it will go provision that. Once the clusters are there, the cluster, that script would on the environment, it would directly pull whatever it needs to get, the binaries or whatever things that it needs, directly pulls from the Artifactory, and then the registration is also done by API. So all this is driven by API and combination of scripts. So this provision process really helped us to, it brought what used to take, because of the lead time and the emails and all that, 4 days, it brought down to like 2 hours. And as I said, once this is done, now everything is, there's a Jira associated. There is, version what's deployed in Git. That is the wrapper what was configured on the server. And from there on, any changes you need to do, we just have to get that changes, configurations updated, and then a pull request gets raised, and that's how the cycle continues. And at any point in time, we can go back in history and verify what changes has been happened. So this is the one use case. The second use case is a patch installs. Again, patch installs, whatever I stated earlier. It could be wrapper config changes. It could be security patches, Mule patches, Log4j XMLs, any patch, right? Any patch, as long as it can run a script, right? All you're essentially doing is you're logging onto the box, you're stopping the server, you're doing an action, some action you're doing. That action could be anything. It could be a script. And then you start the server. And that's what essentially we are doing. And most of these patches, what you get from MuleSoft, that's what they recommend. You have to go to this lib user directory or dump these jars, stop and start the server, you're good, right? So we have that in place. But again, initially, all this was done manually, right? So we were using the old process. There's no central place of tracking, email communication, and all that. And we are losing the visibility of these patches. Again, similar to the cluster setup. Now it's done via pipeline. So you have a record of not only when it got started in Jira, but a pipeline, detailed pipeline log, and that pipeline, once it finishes everything, this is applicable for all pipelines. So it posts a comment in Jira, and then in Jira comment it clearly says who opened the ticket, when it was opened, who executed the pipeline, who triggered the pipeline, what is the pipeline log, what is the state of the pipeline, build status exactly. So we have history of since we are using this, we have a history of going back close to 1.5 years, and at any point in time for any cluster and in any environment, we'll be able to identify what exactly happened, the history of the changes. Just by going through the Jira and the combination of Jira and pipelines, we can quickly figure out because a lot of times when we do things 3 months or 4 months down the lane, the operations team come back and says, hey, certain things are not working. So that's the first place where we go and start our troubleshooting effort. Benefits, again, collaboration, configuration history, we can get it. Standard process is to do the version control and Git. We can get the history of it. Our provisioning times improved significantly. It was days, now it's a couple of hours. Automation of all the changes we talked about. We are able to handle that workload in days instead of weeks. It's days now. And most importantly, we have an auditing. We're auditing the environment changes, ensuring the consistencies and traceability of it. That's all I have. Thank you, everyone, for your time. Manik, back to you. If you have any questions, let me know.
Hey, Sumant. Yeah, thank you. That was a great content and great session. Yeah, we do have a few questions on the chat here. The first one is around, you talked about scripts, I think in the first part of the session, you referred some scripts and
in the governance
configurations. Part? Yeah. I am not sure if the question is, can we see those scripts? I don't know if.
No, I cannot. I cannot share those scripts.
Yeah, because those are like internal. Yes.
Yeah, those are internal, proprietary. But again, there are various scripts, right? So I can just tell you, we use shell scripts, we use Ansible scripts. It varies. Depending on the need. Like I said, so this one, the operations one. As I told you, right? So if you look at most of other than the cluster setup, which is which is a different script, but the operations point of view, if you look at any of the Mule patches, this is a consistent pattern I've seen. Go to log on to the server, stop the server, do some action. Either you update the wrapper config or put a jar file or do something. Right, and that can be scripted. It need not have to be like you don't have to use Ansible, Chef, or anything of that. Right? It's a simple script. Right? So that's what we did. We just whatever the requirement is, we just collected that and making sure that it is scalable. Right? We also want to keep track of what all previous patches we installed. So we store all of that in a central place in Git. So in Git we know all the patches we applied in 3.9 version, or all the patches we applied in 4.x version. So we have a list of that, and as and when we get new patches, we add to that repository. Right. So that is the essence of this patching, and this was the main problem from the operations point of view, because this was all manual work, right? So it used to be weeks, now it's hours and days, right? So yeah.
No. It definitely helps if those are all repeatable steps. It makes sense to like automate those in there. That's good. Thanks. Next one, it's pretty open, but it says, what are the configurations needed to be implemented? I don't.
What configuration? Exactly. That could vary, right?
That's a pretty open question. That's what it is said there. Radhika, if you have any more context around that, please add to the question. Meantime, I'll just move to the next one. Was there a downtime in provisioning cluster updates or applying patches, which
Right.
is
So
right like
we go with a two-node cluster, right? So when it's a
uh
two-node cluster, that means you have MRE running on one node, one VM, and another MRE running another VM. It's a two-node cluster. So I'm creating a cluster with two
mhm,
MREs, right? So the
mhm,
script, what it'll do is it'll log on to the first node, just shuts down that node, it'll apply the patch, bring that MRE up, then it goes to the second one and does that. So it's a rolling update, what we call, right? So rolling
okay,
update patches are all rolling updates. There's no downtime at all. Um, if you're in RTF, then you can do a lot more things. But
yeah,
because
yeah,
you're in a cluster environment, the only option is to do a rolling update.
right. And that is only for like on-prem, even Cloud Hub. If it's Cloud Hub, it's
Right,
better there. But
right,
for on-prem, yeah, that's the only option. Do node by node and
right.
one thing.
And it depends, if the change is significant and if there's a business, we always do changes, patches we do after business hours. And if
Okay,
it's a change that's needed, and if it's a major change, we just do it on the weekend, um,
uh,
just in case. But though it's a rolling update, we still do it, when off business hours.
right. Okay, that's good. So everything that you showed here, the presentation or the approach you did, the question is this particular process more useful to Mule admin team? Is it more of for administration purpose only?
No,
Yeah, all this process now.
no.
Okay.
So I covered all aspects, right? So starting
Yeah.
from, you're starting. I mean, not just Mule. I mean, honestly speaking, any API.
Yeah.
So that process is applicable for any asset, any API. If you're building APIs using any tool, any product, that is a process, because you still need to understand the business, technical, and operational context information that's missing. You want to understand at a high level where the swagger, rammer, all that comes
Mhm.
later, right? Nobody's interested in
Right.
that. They want to at least understand at a high level this information, right? Then when you get into the low level details and this process I laid out, yeah, we are using Colibra. I'm not saying go, purchase Colibra, right? Any governance tool
Yeah.
will help. And why we
Yeah.
leaned onto it? Because it's already available. We don't have to build anything new.
Mhm.
This is again, the exchange is great. Exchange is amazing, right? But it just gives only the context of an API and only technical context of an API. Our problem
Mhm.
is beyond that, right? We want to get
Yeah.
the queue information, how my API is related to UIs, what are my consumers, which business context that belongs to. So combining all of that, that tool made sense for us. And yeah, I mean,
Yeah.
this presentation is not just the operations. The first part is more about your delivery, software delivery. And the second part is about operational efficiencies. So yeah, I've covered the whole aspects. Um,
Right. And I think at one point there was a part where you have a GitHub repo, you modify, you can suggest changes to the configuration. So that means even the developers, if they find something, they can always suggest a change in there. So
right.
everybody was kind of part of this whole
Right. So
process.
the whole purpose is collaborative effort, right? You're
Right,
collecting
right.
information. If I'm putting the data in Colibra or the central tool from the developer context, similarly, the business people
Mm,
can put their business context information. Operations can put their context information. But all we are linking together. We are working in a collaborative way. That's talking about the documentation aspect of it. But in terms of
right.
operations, yes, you're putting your configurations in Git. Now your operations and platform and developer, they're all aligned, right? They know the changes, they know what's coming. Then they can go back in history and find out what has happened to a certain. The developers don't have
Mm,
access to the physical servers. They cannot look at the wrapper config that was actually deployed over there unless they go to the
right,
operations and ask them, can you provide me this wrapper? All they have to
right.
do is go to Git and then find out what is a wrapper for this particular cluster in this environment, and they know that
Mm,
has been deployed.
okay, that makes sense. Thanks. Next one is a good comment between the questions. Awesome work on automating platform for your hybrid. So that's good. Just a comment I wanted to mention, not the question. It's a great work. Yeah. Next is if, for example, if we have like 10 APIs and in the deployments we have changes only to two APIs.
Mhm.
When we deploy into the application, what are the configuration steps need to apply so that only those two, I'm extending the question, only those two APIs are deployed and restarted, but not all remaining 8.
Yeah.
I think this is more around the deployment part, not like an
Okay.
overall.
Yeah.
Right?
So you're in a cluster mode, right?
Yeah.
Actually, let me show you this picture. Probably this
Mhm.
will clarify what you're talking about, right? So
Mhm.
the deployment model is different. So when you're talking about a deployment model in a standalone cluster, so here, think of whichever version that might be, right?
Yeah.
So this is your cluster. You have your 10 APIs, these Muleys here. Those are your
Mhm.
10 Muley apps,
Right.
right?
Yeah.
Out of those, all 10 Muley apps are deployed in that cluster, in that MRE, in that JVM. If that JVM goes down, all 10 go down, right?
Yeah.
So what we're doing is, because there are two of them, we are taking one MRE down. We are doing some patch, and we are bringing that MRE up, and then we're going to the other side and then doing the same thing. So operations-wise, there's no impact, right? Your apps are still working. You have a load balance in front of that. You can still hit that.
Mhm.
Now, coming back to the question, out of 10, you want to deploy 2 apps. Fine, go to the Anypoint platform. You can deploy those 2 apps. We've automated that using pipeline. The pipeline will use Anypoint APIs, Anypoint Runtime Manager APIs. It connects to the Anypoint platform, and it we build the code, pulls the code, builds the code. It checks in into the build code, checks in into Artifactory. We have the binary there. Once the binary is there, we take that binary, we deploy it via API. If that's the standard, deployment process. If you don't have that, that's fine. Go to Anypoint platform. You have the zip file. You can take it, manually deploy it. Either way, there's
Yeah.
nothing operations-wise on a cluster. Yeah, 10 apps are running. You are just updating those 2 apps. There's no
Right.
disruption to the other 10 apps. The
Right.
only disruption will happen if the whole JVM goes down or the MRE goes down, right? There's a
Yeah.
disruption. Yeah,
So
hopefully
it
I
is more.
answered the question.
Sorry. It is more at which level you are working. Is it at
Right.
the application level you are working, or at the whole cluster or this node
Mhm.
level you are working?
Right.
Like all those configuration patches and all that will come
Right.
under like a server level events,
Right.
which can then take down whole your server. Okay, that's good. Going to the next one, can we get some workflow on Mule patching? That's the only question.
Workflow on if you want to really understand the workflow on the Mule patch, these are the steps, right? This is the yeah. So Mule patch workflow, how did I get? I'll tell you how did I get. I just go to any patch documentation support page. It talks you the steps one by one. It
Okay.
states download this particular binary. Okay, what we did, we downloaded that and we put that in the Artifactory. We don't want to deal with MuleSoft, right? Connecting wise. So that's the first step.
Yeah.
Put it in your own repository. If MuleSoft gives us an API to directly download it or do something there, yeah, we can do it. But first, we want to download whatever the instruction says. It's different for different versions. So take one version at a time. Take 3.9. Okay, for 3.9, you need to download the patch binaries. Go download that list of things. Put it in your Artifactory. Then what you do is the second step. You have to connect to the whichever MRE you're talking about. Stop the MRE. Take these binaries, put it in the lib user, or replace some binaries. Whatever the step says, do that. That's the second step. Third step is bring the MRE up. And then if you have a cluster, repeat this for that many number of MREs. That is a workflow.
Yeah.
And if you can automate the piece of how can I connect to an MRE, stop the MRE, perform some action, and start the MRE, and do that for n number of MREs, that is your workflow script. And then you put a wrapper on top of it with pipelines. And then you integrate that with Jira. That's all you got to do. And then you have the complete workflow got together. So that's how we started. Again, that script is a generic script, and it varies for different MREs, different versions. That's why I'm calling that perform action can be generic. And that's what we do. When we get the patch, we just go and we work on that script. That action is what we work on because our boilerplate process is already baked in.
Yeah, no, that's helpful. Thanks. Next question is very simple and generic. What is GitOps?
GitOps, it's a term where you have the declarative state of your configurations, you manage them in Git. So example, wrapper config. Wrapper config, if you know this is a wrapper config and that is the only wrapper config that is actually deployed, and all the version control and management, you're doing it in Git, you're maintaining the version history of it, changes of it, and then all the proposed changes, you're getting them as pull request, and you're pushing that via pipelines, right? So you're doing operations with Git as the source. The declarative state of your configuration is maintained and managed in Git, version control. So that's what GitOps is. And that's what we did. All our configurations are maintained in Git. The declarative state of my runtime servers is maintained in Git. I mean, you can go to another level and have a lot more things, but at a cluster level, this is what it is. But it means different if you go to runtime fabric. It's different. There you're talking about YAML files and actual configurations and all that, right? But yeah, that's what.
No, it makes sense. Like it will differ based on your target deployment environment, right? Yeah. Next one is, which I also had that question. So it's the same thing. So you have on-prem solutions. Are they Dockerized, or do you have any environments where you are using Dockerized environment to deploy your APIs or Mule? Do you have anything like that, or it's the typical?
It's a traditional way of get two VMs, Red Hat Linux, or whatever, any Linux framework. Get two VMs, install JDK. Now it's Open JDK, right? So install your JDK, and then you get the binaries. That's it. You're done, right? So doing that at scale is a challenge, right? But the process is still the same. Yeah, we've not Dockerized any of that, and
Okay, and like Dockerized will be a completely different approach than.
Yeah, I mean, runtime fabric is there. If you really want to run Mule in containers, and why do it all by yourself when Mule is already providing runtime fabric? It's much it's a container orchestrator tool built on Kubernetes, so you get all the things baked in already in there.
Right. Okay. Next one, I noticed you showed multiple runtime versions versus runtime fabric in your hosted runtime plane. How do you manage all of that from a Mule configuration perspective and from Mule deployment perspective?
Very good question. So the way we've done our groundwork is we realized, as a platform owner, the data I was showing, the numbers I was showing, we've realized that this at a very early stage. We're going to get a lot of work, and how are we going to decouple this, and how are we going to ensure that there is decoupling at the same time. We should be able to move things much faster. So what we've done is we've divided our workloads depending on the geography, depending on the business function, depending on the criticality of it, several factors that weighs in. And that's what I call that as a discovery phase, right? In this phase, this is what this discussion is what, as a platform owner, I ask developers, like, what is your workload? Where they are being deployed, which geography region, things like a lot of questions, So, and based on that, we've isolated our clusters, whether it's on-prem or AWS, so this, if the cluster is already available, and if it's adding like a couple of services to an existing cluster, it's straightforward, right? The bootstrapping process will take care of, and the developer is good to go. He has a capacity, he can deploy it, and he can good to go. But if you're talking about a brand new project, brand new environment, a brand new cluster, then that takes effort. You need to get new VMs, how you want to isolate it. Again, depending on the criticality, business function, and certain business function needs a dedicated cluster, certain business function is okay to merge with other clusters. So that is done during this assessment phase. And yeah, I mean, we've called platforms, we have different platforms, and distributed globally, and we manage it that. And we know for each platform we have again, all these APIs are there, right? The Mule provides APIs, the Anypoint platform APIs. So we created a dashboard and we pull the details. We assign some non-technical information, technical information that gets pulled from here, and we have a dashboard that tells us how many APIs we've deployed, what stage they're in. We can filter that information out, and we get the Mule version numbers, which platform uses which Mule version, the status of that app, status of the servers, all that. It's a nice dashboard that we look at. And planning also, that's how we plan, right? So we have combination of versions, and we cannot just, we should be able to move things faster. At the same time, we need to look at the stability of the overall platform as well. So we have we have mix of both versions.
Yeah. And I think it's very subjective decision,
Right.
Or the scenario whether to run into same runtime or you want to have spin up a new runtime. It all depends on your load, what kind of application, like you were saying, business function, whether it is okay for that critical function to be part of other functions. Like sometimes some function is very critical and it shouldn't go down at any cost.
Right.
So you might make sense to have it.
And there might be compliance, regulatory reasons. If it's a compliance or regulatory reason, you have to be on-prem, and it has to be an isolated network. So only certain individuals should have access to that. And so there are several factors you need to look at when you're looking at operations at scale, right? So
example could be if you are processing a credit card transaction.
Right. PCI compliance requires a dedicated infrastructure, right? So you need to have a dedicated environment for that. Yeah, whether you have 5 apps or 10 apps or 100 apps, it has to be isolated.
Right? Yeah, that's true. So that's good. That's good. It's interesting question. Next one. Any reason of having so many applications? I think you showed 600 or something in one of the slides.
Yeah, any reason? That's how it gets started, right? So most of our projects are migration projects. We are doing a lot of migration work from other. Mule is not just an API platform; it's also an ESB platform. People are forgetting that, right? That is the history of Mule, right? It's out there. So yeah, we are doing a lot of migration projects, and some of the work we have to migrate it to a new platform. That's the number we ended up with, whether you like it or not, right? So that's the number. We are not an org that's starting like, oh, let's throw everything out, do everything from scratch. If you're doing that, microservices, design first approach, you can apply all those best practices and you can ideally implement it. But we are a huge org. There's global teams, right? And some are migration projects, some are design first projects, and we should be able to cater to both workloads.
Yeah, that's true. And I think if you talk about migrations, one of the difference when we compare could be your previous, for example, ETL tool was a single software, single ETL tool. Now, when you go into Mule mode, you might create a one Mule app for each job that was internally happening in there, and that could blow up your numbers.
Right.
Oh, you have like suddenly 300 Mule apps running there because you was running 300 jobs in that single ETL tool. Right?
Exactly.
So yeah,
I mean, not exactly like that, right? But what I'm saying is, the number why it's that huge is you're not starting from ground zero. You're already starting from an existing requirement. It's already there. The source and the target is there. The requirement's already been defined. But taking that and you're doing a technology transformation here, right? You're replacing a classic technology with MuleSoft, right? So that is another workload, right? If you're design first, design first might have only fewer services, right?
Yes.
We have combination of both. We have all flavors.
That's good. It's a wide topic. I mean, there are a lot of ends to it.
Right.
That's good. So next one is not a question, but the slides are very useful and insightful. Do we get access to them? If it's okay, you can send me the slide link, Sumant, and I will upload them on the event page, and you guys can always go back and see the slides on there.
Sure.
Yeah. So are you using microservices architecture? touched briefly on the previous question for that.
Yes,
But
we do.
is
We
there
do have
anything new?
microservices.
Mhm.
Again, as I told you, right, depending on the workload.
Yes.
Uh, the newer greenfield applications is microservices, right? If it's a migration project, we try to do as much microservices as possible wherever it's needed. But certain requirements are hard stone. You cannot change that because there's a business impact associated with that. So those
Right.
services, we are just doing, the gain is showing the technology transformation, right?
Yes. Yes.
Combination
Yes.
of both.
Yeah.
Yeah, all the
That's good.
greenfield is microservices. We have a microservices architecture, and that's why we were emphasizing more on this API governance, because it's not about just
Mhm.
APIs, because we have async APIs. We have interaction between APIs. You could
Okay.
have a Spring Boot API or a Mule API. How
Mhm.
are they interacted? It's not Mule, but again, you need to show the dependencies,
Yeah.
right? How is
That's
it
right.
interacted to your consumers? The consumer could be an external consumer, or it could be a UI application, internal UI application, or it could be an internal user. So that relationship,
Right.
right?
Yeah.
Yeah, this is following all the modern microservices based architecture.
Okay. We are at time, but I think we have only two questions left, so we can just quickly take those if that is fine.
Yeah, sure. Go ahead.
So, is there a limitation on the number of clusters you have in MRE or the number of APIs in a cluster? How do you manage that, or how do you
Uh,
define basically
right.
the
Very
upper
good
limits,
question.
you can say?
Very good question. Very managed. So when
Mhm.
you're talking about operations at this scale, we put a restriction that no more than 25, no more than 30 APIs or 30 applications. I would call 30 services in a cluster. And if there is a need, if there is a need, that particular line of business needs more than 30 applications. Let's say it has like 60 applications or 45 applications. We create two
Mhm.
different clusters for it. We have naming conventions and standards for it, right? So we just put a limit to ourselves. Uh, Technically speaking, you can put all 100 apps in one cluster. You can do it. Nobody says not to do it. But operationally, there'll be challenges, and it increases the risk. You're putting 100 apps in like one JVM. And even if like one or two apps consumes your resources, the whole cluster or whole JVM goes down. That's the downside of it. So you need to have a right balance, right? If it's proxies, yeah, you can go 30, 35 because proxies are very lightweight. It doesn't impact. But when you're talking about migration projects, which has a lot of custom logic in it, they are resource
Mhm.
intensive. So
Yeah.
again, all that is done in the assessment phase, right? We look at, hey, what are your workloads look like? Are these proxies? Are these simple pass-through APIs? Are these like intensive logic? Do you need isolation, right? So at a bare minimum, we just put like 30 if it's like a lightweight. But if it's intensive, we even further restrict that. Depending, we need to look at the workload and we isolate clusters based on that. Yeah,
So
I mean,
it's like
it's
just
a it's a
just to make
hard
sure.
it's a hard question, but yeah, we run into that all the time, and because all we don't want is we create a cluster and we don't want to have surprises like when you do UAT testing and the whole JVM goes down. Now you have to go back and then troubleshoot it. We want to do that work upfront, design
Yeah.
it properly, and then scale it out, as needed, and then
Right.
isolate it. If one app is huge, heavy load transaction, okay, fine, I'm going to give you a dedicated cluster for that workload,
Right.
right? So again, it varies, and only thing that happens is we brought the process of in the discovery and the assessment phase rather than realizing that at a later point. So we
Right.
can plan that much better initially, and then we don't have to worry about it once it's out there.
Right. I think the important one question you could ask is when you're adding a new application to a cluster, the question could be, are you going to be a noisy neighbor? Are
Right,
you gonna create like a lot of noise that will
right,
affect other apps?
right.
If you say yes, then probably let's review should you be in your own cluster or somewhere else, right? Yeah. That's a good one. Yeah, that's for sure. Probably the last question, would you advise having multiple runtime versions, 3.9.2 or 4.2.2 within same Mule cluster? or would you
No,
suggest having identical Mule runtimes? I doubt
no.
that is even possible. You
That's
cannot
not
even
even
do that.
possible
Yeah,
because the underlying runtime engine is different in 4.x.
yeah. You
And
cannot
even
create
if it's
cluster.
possible, why you want to mix and match? If you really want, like, okay, I want to have 3.9, 4.x, go RTF. That's your friend. Each
Yeah,
Mule app is a different color. So each Mule app, this one can be 3.9, this one can be 3.1, 9.1, this is 4.2, 4.3 is also getting released. So the benefit in runtime fabric is each application gets its own runtime. That's beauty, because now you moved out of all those 10 apps or 20 apps deployed on a single JVM. You decouple from that. I don't have to get tied to that JVM. I don't have to increase my risk because of that JVM going down. Now each app has its own life cycle. Each app can run its own JVM. Each app can independently scale. Each app can independently upgrade. So if that's your
you cannot
requirement,
be a noisy neighbor.
yeah.
Like you cannot be a noisy neighbor
You
in
can
the
also
sense.
be a noisy neighbor because only your app gonna go
Yeah,
down,
so you can't trouble others in that case,
right?
right?
And
Yeah,
you allocate resource limits, right? There is a resource limit for every Mule app that runs in RTF. So if you
Y-
go beyond that, that's fine. You're only one going to go down, and that's fine because the others are not complaining here. In this case, you got to be a lot more thorough in your analysis. Here, all you have to do is keep on adding more worker nodes,
right.
and then you're good. You're adding more
That's
capacity, and that's the only model you're looking at.
that's right. We are 5 minutes over, and if I really look at it, there's only one question, and
That's fine. Shoot.
yeah. What is the use case of Log4j pipeline in GitOps? I don't want it to just leave that out. So let's conclude
So
on
the
that one.
log4j is, if you look at every app, right? Every app has a log4j XML, right?
Yeah.
So think of that in scale. Now you have 1,000 of those applications in 5 different environments, right? 5,000. I'm just giving you the numbers. So what would be now? What happens is now all those 1,000 won't have a same requirement. Some of them they don't need to log extensively. Some of them need to have extensive logging. Some of them, because these are isolated or separated in different clusters, different MREs, different geography regions. Some are compliance regulatory regions, right? So different logging requirements for different applications. So every time you want to make a change, you have to open your code in your studio. You need to update your log4j XML file in there. You have to repackage, rebuild, redeploy. Think of that, doing that 5,000 times parallelly. It's hard to manage at that scale. So what we've done is there is a configuration where you can say, hey, my log4j is externally located at this location, right? It's externally located here. You can put that in your Mule properties. So that's what we do. And we are saying my log4j is not within my Mule package. It's externally located. And as long as it's there, I'm good. I can start my application. So within your cluster, what we did is you have 25 apps in your cluster. So we created a location for that on that host. We have all those 25 related log4j files there. Now, using a pipeline and automation, I can control the pattern. I can have a common pattern for all of them for that cluster. And I can have a common standard. I can say, these things should go to Splunk, or these things should also go to Splunk as well as this. So you can have multiple possibilities if it's externalized, and you can control at a platform level. Some have unique requirements. And we did that at scale because now I can control any log4j application XML file. If they come back and they'll say, hey, for all my clusters, I need this many logs, and I need for this long, I need to maintain the history. That's fine. You don't have to touch your apps. I can just run a pipeline and I can make it happen. So that's the reason why we externalize, and that's only happens in the standalone cluster model. You cannot do that in a Kubernetes. Kubernetes it's all different. But here you have that flexibility of changing your patterns.
Yeah.
Hope I answered that question.
Yes, I think we pretty much covered all the questions. We did not leave out anything, so that's good. Thank you for
Okay.
extra time. And I think we can conclude it here. It was an amazing session, Sumant. A lot of good content, good question answers. So thank you very much for letting us see all this content here. And for people watching or whoever missed it, this recording of this session will be available on our channel maybe in 5 or 10 minutes after the event ends. On the event page, you can go back and you can see the recording there as well as slides. Hopefully, I'll be able to upload slides there so you can see it there too. Any last thought, Suman?
No, thanks. It was wonderful. Good set of questions that were asked.
All right. Thank you, everyone. Stay safe, stay healthy. Talk to you later in next session. Thanks.